I'm standing in for Keith, who was going to give the presentation originally, but he's a casualty of the little problem with volcanic ash. I'm going to give you a short introduction to our newest baby, open source baby. It's release 1.0.1 as of last month, and it is address family transition router. It's not translating, it's transitioning. And it is not going to be a heavy technical presentation, apologies. It's going to be more about what the product does and where it fits into the solution space. If we get to the questions and the questions get a little bit too technical, I'm going to be very happy to take the questions away with me and provide the answers afterwards. And I'm going to pick on Emma and ask her to take down for me any of the questions that don't get answered in the presentation. Thank you. So I think everybody probably knows who we are. We are Internet Systems Consortium. We're based in California. We make open source stuff. Paul Vixie is our president. The open source stuff that we are known for is predominantly bind, but we also do DHCP, and now we have AFTR as well as part of our portfolio. We also run FRoot and various other things, and we are heavily involved in the protocol development world.
Catherine, can I just stop for a second? Have you got a phone that you
No.
mobile phone? No. Because we can hear your mobile phone and get it on webcast. Is there any It's coming from somewhere.
Is it yours?
Yeah,
Oh, okay, fine.
okay.
No. So it's the same story as the last presentation. How do we successfully move from IPv4 to IPv6, given that IPv4 is running out? It's not a problem for the end users. The end users are just wanting everything to work. There is nothing magic that moving to IPv6 is going to bring to the end users. As far as they're concerned, they just want it to work, but it is a problem for the ISPs who are finding themselves in the position of no longer being able to hand out addresses or provision the addresses to their users. So sooner or later, we've got to tackle it. But it is at the point where, okay, it's a little bit rolled out. Not all places that you want to go on the internet provide IPv6 connectivity. Very few of them do. So if you give IPv6 only to all of your users, what's going to happen? And also, at the end user point, a lot of end users are running old applications, old hardware. How do you make it work for them if you're in a position of wanting to roll it out? So we need a way to implement it, but in a phased fashion, so that you can roll out the IPv6 and get people using it, but you still don't break things for everyone who is still stuck using IPv4 in part or in total. So this is a solution that attempts to fit into that space for an ISP who is wanting to roll out IPv6 to their users, but not break it for the majority of their customers. So after address family transition router, I've heard it written down as translation, but it's not, it's transition, is an implementation of the Dual Stack-lite protocol specification draft. It's actually one variant of carrier-grade NAT, and it allows you to deploy IPv6 and IPv4 at the same time, but it's not NATing the IPv6 component. It's NATing the IPv4 component, so it's a different space from the previous presentation. What it does is it works by putting together two different technologies, that two key technologies. One is to encapsulate the IPv4 within the IPv6, and we know how to encapsulate. And the other thing we are providing IPv4 NAT as part of that. It's intended for the big broadband environments, and it's implemented at the central point. Sort of, if you think about this, you have got hundreds, thousands of consumers out there, and you don't want to make it complicated at the consumer end, so the complexity is done at the central point inside the ISP's control in the afterbox. So one after router can handle many, many, many clients. So it's using the Dual Stack-lite protocol, and what that does is it creates a tunnel, an encapsulated tunnel, between the end user box, and that's going to be called the B4, before, after, play on words. Have lots of fun with that. So it creates a tunnel between the user's IPv4 environment over the IPv6 infrastructure that's just been rolled out to the afterbox, in order then to route their IPv4 traffic out to the IPv4 internet. At the consumer end, you've got a B4 box that deals with the location of the after endpoint and creates the tunnel for you and does the encapsulation. Now, I said that there is NAT involved. The NAT is not done at the consumer end. The NAT is done at the afterbox end of the solution. There'll be a picture later. So at the after end, the box that you've deployed as part of your infrastructure, it accepts all the tunnels from the various B4 boxes that are deployed at the consumer end. It unpacks or decapsulates the tunnel traffic. And at that point, it does the NATing between all of the various IPv4 connections that are coming over the tunnel and the IPv4 world out there. So, Adrian, that's how the solution is different from the one that you were looking at, which is fascinating. It also has to manage at that point all of the controls, all of the keeping track, all of the audit, all of the security, etc. So, after 1.0 is something we started working on as a proof of concept of the draft of the DS-lite protocol. We were asked to do it by Comcast, who were interested in knowing if it would feasibly work. The thing is, you write all of these protocols, but until somebody actually goes out and deploys them and tries them in practice, you don't know if they're really going to work in practice, if they're going to scale. So this is proof of concept to see if it's a viable solution to the rolling out of IPv6. And it's got two components. It's got the afterbox, which is the ISP end, the carrier grade end of it. And you've got the B4 component, which you roll out onto the basic commodity router. Okay, and the picture. I haven't got a pointer. Okay, what the picture is showing here is a couple of examples of consumers in your network. And they're running standard IPv4 space. And we hope also IPv6 space. And I'm going to wave arms here and say there is magic here for how we do the connectivity, provision of the addresses, the IPv6 addresses, because that's not what this solution is about. That's taken for granted that you have rolled out your IPv6 only solution to your consumers in terms of infrastructure, but the IPv4 side of it is handled by the after solution. So we have IPv6 going to these B4 boxes, and the B4 boxes are interfacing to the user environment, me with my laptop, my elderly parents with their ancient laptops that don't support IPv6, my children with their games that won't run over IPv6, and so on. All of those are handled and go into the B4 box. If you have people there running IPv6, then the B4 box is transparent. It's just going to route into the IPv6 internet, which is coloured blue there and is much, much smaller at the moment. If, on the other hand, we want to route IPv4 traffic, then that goes through the tunnel, over the IPv6 to the afterbox. The afterbox then decapsulates it, does translation, and then forwards it off into the IPv4 destination and back. The other thing that's key with the solution is that because the address translation is done centrally by the afterbox, you don't have to have as many IP addresses. You can share, or with thinking of up to about 100 consumers with one NATed IPv4 address. So you don't need as many IPv4 addresses to provide the connectivity to the IPv4 world using this. Okay, I did say it was our newest baby, and release 1 has got some fairly key limitations. No UPnP, no configurable customer-initiated port forwarding, and the configuration is... So, okay, it's release 1. We're getting there. There will be other releases. We're planning in 1.1 to introduce UPnP, a web portal, XML backend, better logging tools, improved documentation. And release 1.1 is due out at the end of Q2, and I checked earlier and we're still on schedule for that. And we have Comcast actually trialling the software that they wanted us to produce. They'll be rolling out a field trial late in 2010. I think I read somewhere recently that there was an announcement that they were going to do that on one of the news groups. They certainly said something about when they're planning to deploy it, independently of talking about after. There's going to be a 1.2 release. I'm sure if there's enough interest in it, there will be further releases as well. The 1.2 release, though, is going to focus on making the whole implementation more streamlined. You start off, you implement it, and you make it work, and then you look at how you can optimize it to make it work better. And, of course, when you take things out into the field and try them for real, you find out all of the bits that you hadn't foreseen when you were writing the protocol. You can design something and you can produce it and it works beautifully in a test environment, but you take it out, you take your nice sleek new car out into the road and people drive it through sand, through hailstorms, through they park it in strange places. So that's the point where we'll start from the field test to iron out some of the features and fickleness that is discovered as a result of deploying it in real life. It's a community project, like all of our open source. We have a track site that has got all the code for everyone to see. It's got bug submission facility, and we've got a community wiki. So if you're interested in having a look or having a play with it or joining in the development, that would be the first place to go. We have mailing lists. The development model okay. We have dedicated engineers, we have a product manager, we have community participation, we have product planning, everything that you would expect from a well-managed open source software. But the funding model is open source, and therefore we need sponsorship, we need interest, we need a funding model to make it happen. So we're maintaining it. We have got sponsorship at the moment, but we would like community participation. If you think it works for you, then come and join us. We have a forum. And the forum is part of the funding model. So donations, membership. If you join us and join the community who is interested in the AFTR, then you get a say in the direction it takes. You get input into the next features that will be rolled into it. We also have, we did a tech talk, a Google Tech Talk in January. It's about 50 minutes long, and it covers all of the technical details that I conveniently glossed over and said, it works by magic. The details are in there, and as I say, I'll be able to take questions away with me. I know some of the answers. I don't have the full technical details because I haven't worked on the development of AFTR. Any questions, having said that I won't have any answers? Yeah. You might have to come up here.
Okay, so it looks like this is a reference implementation of the AFTR size.
It's a reference implementation, yes.
Is there a similar reference implementation beforehand as well? Does that exist anywhere?
Well, the software is the reference implementation. So we have built the AFTR component and we built the B4 component.
Okay, so this contains both.
Yes, both components are there, and they're both downloadable from the site. And we have we needed to use the B4 component in order to try it out and make sure it works. So we've used that as well. Yeah. Oh, they do have a microphone.
Okay, thank you very much indeed.